If hell exists, it isn't underground, it's right above our heads. It hangs in the sky as a bright, alluring point that poets have called the morning star and the symbol of love for centuries. But behind this beautiful facade lies a world that seems designed to destroy anything living or mechanical. This is Venus, a planet where it rains not water, but concentrated sulfuric acid that evaporates before it hits the ground. A planet where the sky isn't blue or black, but a dirty orange color, resembling the glow of an eternal fire. A planet where the atmosphere is so dense and heavy it can crush a nuclear submarine as easily as you crumple an empty soda can. And it was into this furnace, this cosmic blast furnace, that the Soviet Union, with a persistence bordering on madness, sent its automatic stations time and time again. In the West, Venus was called the Soviet planet for a long time. This wasn't a joke or an exaggeration. While American programs like Mariner preferred safe flybys and photography from a respectful distance, Soviet engineers chose the path of direct contact, the path of a battering ram. They literally bombarded Venus with metal, trying to find the bottom of this ocean of superheated gas. It was a race not just for first place, but to understand the limits of the possible. Imagine the task. You have to create a robot that must fly millions of miles through the icy void of space, then enter an atmosphere at escape velocity, survive G-forces that burst blood vessels, open a parachute in a hurricane where the wind blows at 200 miles an hour, and finally, land softly on a scorching frying pan. And not just land, but turn on a transmitter and tell us what it sees. Decades ago, astronomers looked at Venus with hope. Clouds hid the surface, and human imagination painted pictures full of life there. Scientists quite seriously believed that since Venus is slightly closer to the Sun than Earth, the climate there should be similar to our tropical period. In their imagination, endless jungles, giant ferns, warm oceans, and perhaps even dinosaurs were hidden under the thick clouds. Science fiction writers wrote novels about the colonization of Venus, about cities under domes and meetings with brothers in reason. No one could imagine that a real branch of hell was hidden under this white blanket. Reality turned out to be scarier than any nightmare. The surface temperature reaches 860, sometimes 900 degrees Fahrenheit. That's enough to melt lead, tin, and zinc. If you put a piece of lead on a rock on Venus, it would turn into a puddle in seconds. The pressure there is 90 atmospheres. To feel such pressure on Earth, you would have to dive into the ocean to a depth of almost 3,000 feet. At that depth, water presses on every square inch of your body with crushing force. Now imagine that happening not in water, but in superheated gas. Yet the Soviet Union decided it had to be there. This was one of the most dramatic and expensive pages in the history of astronautics. Why did a country spend colossal resources, billions of rubles, and the best engineering minds to send complex and expensive machines to certain death again and again? The answer lies in human nature itself, and of course in the logic of the Cold War. But there was something more. It was a challenge to nature itself. Could the human mind create something capable of surviving where matter strives to disintegrate? The Venera program became a unique technical feat, the records of which have not been broken to this day. No other country has been able to land a craft on Venus and transmit color photos and sound from there, only the USSR. And today, we will walk this path again. From the first naive attempts and crushed hulls to the triumph of engineering thought, when the voice of another planet was heard for the first time in mission control. The history of conquering Venus began not with triumph, but with a series of bitter disappointments and mistakes paid for with years of labor. In the early 60s of the 20th century, humanity knew negligible little about Venus. Everything was built on hypotheses. Chief designer Sergei Korolev and his team worked practically blind. When the first Venera series probes were designed, engineers faced a question. What pressure should the lander's hull be designed for? There was no exact data. There were only assumptions from astronomers who, looking through telescopes, believed that the atmosphere of Venus was denser than Earth's, but not by much. Maybe 5 atmospheres, maybe 10. To be safe, they decided to count on 20 atmospheres. It seemed more than enough. After all, 20 atmospheres is the pressure of water at a depth of 600 feet. What gas could be denser? How cruel their mistake was. The first launches were plagued by failures unrelated to the planet itself. Rockets exploded at launch, booster blocks failed, and stations remained in Earth orbit, turning into useless space junk. Venera 1, launched back in 1961, became the first spacecraft to fly past another planet, but contact with it was lost long before the approach. It rushed past Venus as dead weight, transmitting not a bit of information. Venera 2 and Venera 3 suffered the same fate, loss of communication. But Venera 3 still managed to reach the surface, becoming the first man-made object to touch another planet. True, it wasn't a soft landing, but a hard crash. It simply smashed into the planet at high speed, and we never learned what happened to it in those final seconds. The real drama played out in 1967 with the flight of Venera 4. This was a mission of hope. The craft was brilliantly designed for the conditions scientists expected. It was supposed to enter the atmosphere, deploy a parachute, and drift down smoothly, transmitting data on air composition, temperature, and pressure. At first, everything went according to plan. The lander separated, entered the atmosphere, G-forces reached 300 units, but the hardware held. The parachute opened. The antennas started working. Celebration began in mission control. Telemetry was coming in. Recorders traced graphs. Scientists watched the temperature rise, 100 degrees, 200, 400 degrees Fahrenheit. The pressure was also rising rapidly. 1 atmosphere, 5, 10, 15. And then the signal cut off. Suddenly, without warning. What happened? Engineers looked at the last data received. The altimeter showed the craft was still 17 miles above the surface. But the pressure at that moment had already reached the limit the hull was designed for, 20 atmospheres. The terrible truth became clear. Venera 4 didn't crash. It was crushed. The planet's atmosphere squeezed the strong metal sphere as easily as an eggshell. The station died while still in the sky, never even seeing the surface. It was a shock. The data transmitted by Venera 4 before its death overturned all ideas about the solar system. It became clear there were no jungles on Venus, no oceans, and certainly no dinosaurs. A monstrous greenhouse effect reigns there. The atmosphere consists almost entirely of carbon dioxide, which acts like a blanket, trapping solar heat and heating the planet to smelting furnace temperatures. But the scariest part was the pressure. Extrapolation of the data showed that at the surface, it should be not 20, but around 90 or even 100 atmospheres. This meant all previous projects had to be thrown in the trash. All blueprints, all calculations, everything was useless. They had to start from scratch. Engineers had to create not just a spaceship, but a real deep-sea bathyscaphe capable of flying in space. It was an engineering task of incredible complexity. Making the device stronger meant making it heavier. But the launch vehicle had its limits on payload capacity. You couldn't weigh down the structure indefinitely. It simply wouldn't take off. Compromises had to be made. The next probes, Venera 5 and Venera 6, were modified. Their hulls were reinforced. Now they could withstand 25 or even 30 atmospheres. But the creators understood. This was still not enough to reach the bottom of this aerial ocean. These missions were a kind of suicide scouts. Their task was simple: descend as deep as possible, transmit data, and die, refining the atmospheric model for the next real assault. And so it happened. They transmitted data longer, descended lower, but eventually were also crushed by monstrous pressure at an altitude of about 12 miles. Soviet engineers found themselves in a situation where nature seemed to be laughing at them. Every time they took a step forward, Venus raised the bar of difficulty. But retreating was not in the rules of that era. A decision was made to create a fundamentally new device. Venera 7 was to become the very hammer that would smash the planet's impregnable armor. The lander's hull was now made not of aluminum-magnesium alloys, but of titanium. It was no longer just an instrument container, but a solid cast metal sphere with thick walls. The portholes were removed. Glass wouldn't hold. The number of scientific instruments was reduced to a minimum to save weight for armor, all for one goal: to survive. To survive at any cost, at least for a few minutes, and touch the ground. To understand the complexity of the task, inside this titanium sphere, a comfortable temperature for electronics had to be maintained, about 70 degrees Fahrenheit, while outside hell raged at 900 degrees. For this, a unique thermal protection system was used. Before launch, the device was specially cooled to store cold. The internal insulation resembled a layer cake of fiberglass and asbestos. It was a thermos in reverse. It was supposed to keep heat out, not in. But there was another problem: time. While the device descends on a parachute, it slowly heats up. If the descent is too long, the electronics will cook before landing. If the descent is too fast, the device will smash on impact. Engineers had to calculate the perfect balance. The parachute area had to be such that it flew through the atmosphere as quickly as possible, but braked right at the ground. And all this in conditions of turbulence about which no one really knew anything. The Venera 7 project became the apotheosis of engineering stubbornness. People needed to prove that metal created on Earth could lie on the surface of Venus and not turn into a puddle. The year was 1970, a year that would forever change the history of space exploration. In August, a rocket carrying Venera 7 launched from the Baikonur Cosmodrome. This wasn't just another attempt, it was the decisive battle. 4 months of flight went normally. In December, the station approached the planet. The lander separated from the orbiter and began its deadly descent. Entry into the atmosphere went smoothly. The titanium hull took the hit. G-forces subsided, the parachute compartment cover blew off, and the canopy opened above the craft. The most tense stage began, the descent into the fiery abyss. Silence reigned in mission control. Operators watched the telemetry numbers. The outside temperature grew at a frightening speed: 400 degrees, 600, 700. Pressure crawled upward, striving toward the calculated 90 atmospheres. But Venera 7 held on. It had already passed the mark where its predecessors perished. 12 miles to the surface, 6 miles. And then problems began. Telemetry showed the craft started swinging. Apparently, the winds in Venus's atmosphere were much stronger than assumed. And then the thing they feared most happened. The parachute failed. No, it didn't burn up, but apparently, due to the high temperature, the lines began to melt, or the parachute fabric tore under the pressure of the dense, viscous gas. The descent speed increased sharply. Instead of a smooth glide, Venera 7 began to fall. According to calculations, the impact speed on the surface was about 37 miles per hour. That's like crashing into a wall in a car without a seatbelt. The impact was terrible. In mission control, the signal vanished. Operators took off their headsets. Someone hit the table with a fist in despair. Failure again? Silence again? It seemed an evil fate haunted the program. The planet won again. Officially, it was announced that the craft reached the surface, but communication was lost. However, the engineers didn't give up. They began to study the signal recording in detail, cleaning it of cosmic noise. They played the tape again and again, using the most powerful computers of the time to filter interference. And suddenly, through the crackle and white noise, a weak, barely distinguishable voice broke through. It wasn't a mistake. It was the carrier frequency signal. The machine was alive. It turned out that upon impact, Venera 7 fell on its side. Its antenna, designed to point vertically up at Earth, was now looking somewhere toward the horizon. The signal was going off into the void, and only a small part of it, reflecting and scattering, reached us. But it was enough. Decoding showed the incredible. Telemetry came from the surface for 23 minutes. 23 minutes. Think about that. 23 minutes of complex electronics working in conditions where everything living dies instantly. Venera 7 transmitted the exact temperature, 887 degrees Fahrenheit. Pressure, 90 atmospheres, give or take 15. This was the first signal in human history transmitted from the surface of another planet. We heard the voice of Venus, and this voice told us, "It is hell here, but I am standing." This was a colossal success. The titanium sphere passed the exam. The Soviet Union proved that landing was possible. But this was only the beginning. 23 minutes is not enough. And most importantly, we had no eyes. We knew the numbers, temperature, pressure, atmosphere composition, but we were still blind. What does this world look like? Is it like an earthly desert? Or is it an ocean of lava? Are there mountains? What color is the sky? Only photographs could answer these questions. The next stage was a task that seemed technically impossible, even for science fiction writers, to take a photograph inside a furnace. How? Any glass would crack from the temperature difference or cloud up from acid. Film would melt instantly. Camera electronics would fail from overheating. A way had to be invented to hide the camera deep inside the cooled hull and look at the world through a special porthole that would withstand pressure of 100 atmospheres and temperatures of 900 degrees. Thus was born a series of new generation spacecraft, Venera 9 and Venera 10, and then their more advanced heirs, Venera 13 and Venera 14. These machines were the pinnacle of Soviet engineering thought. Heavy, weighing almost 5 tons at launch, they carried not just sensors, but full-fledged telephotometers. That's what space cameras were called at the time. October 1975. Venera 9 lands softly on the surface. Unlike number 7, it has a special toroidal shock absorber, a metal ring at the base designed to soften the blow and keep the craft from tipping over. The landing goes perfectly. The covers protecting the camera portholes are blown off by explosive charges. And then, a few minutes later, on Earth, in the deep space communication room, a strip of image begins to crawl out. At first, it's just lines, noise, interference, but then outlines begin to emerge from the chaos. Rocks, sharp, angular rocks, not melted as many thought, but fresh, as if recently split. Shadows, the horizon line. This was the world's first black and white panorama transmitted from the surface of another planet. Humanity saw for the first time a landscape of an alien world hidden under clouds. It was a gloomy, majestic sight, a rocky desert flooded with bright but scattered light, where there are no shadows from the sun because the sun itself is hidden behind a thick veil of clouds. But engineers weren't satisfied with a black and white picture. They wanted to see color. What color is Venus? Scientists argued until they were hoarse. Some said that due to the dense atmosphere, light would refract so that everything would appear red. Others bet on green. Venera 13 and Venera 14 were supposed to give the answer. The launch of these stations took place in 1981. These were true robot laboratories. They were supposed to not just photograph, but taste Venus, drill the soil, take a sample inside a sealed compartment, and conduct a chemical analysis. And all this in those short minutes before the device overheated and died. The scenario of these missions resembled an action movie where every second counts. The device has a resource of cold, about an hour, maximum 2. In this time, everything must be done. Venera 13 landed in the Phoebe Regio. Explosive charges fired, camera covers flew off. The transmission of a color panorama began, and the world gasped. Everything around was flooded with piercing orange-yellow light. The sky was yellow. The rocks were brownish, but in this strange lighting seemed orange. Even the white part of the lander's hull looked yellow in the photo. It was a world of eternal twilight, where there is never a clear day. The atmosphere scatters the blue part of the spectrum so strongly that only red, orange, and yellow rays reach the surface. But Venera 13 did something more than just take photos. A microphone was installed on board. Engineers decided to take a chance and try to record sound. What is the probability of hearing something in a dead world? But they turned on the recording, and when the data arrived on Earth, we heard it. A dull, low, crushing hum. It was the sound of the Venusian wind blowing in an atmosphere as dense as water. It wasn't a whistle, like on Earth, but a hum similar to the noise of massive ventilation or the roar of a fire in a furnace. We heard the breathing of the killer planet. However, the triumph of the program was overshadowed by curious, almost anecdotal failures, which showed how treacherous this planet is. The story with Venera 14 became a legend among engineers and an example of how one small detail can ruin an experiment costing millions. The task was as follows. The device lands, a special drill bores a depression in the soil, and next to it, a special spring-loaded arm descends, a penetrometer. It is supposed to strike the ground to measure its hardness and density. Simple. The craft landed. Explosive charges fired, shooting off protective covers from the camera lenses. The cover, as intended, flew off and landed on the ground right in front of the device. And as luck would have it, it fell exactly on the spot where the penetrometer spike struck a second later. Instead of measuring the hardness of the Venusian rock, the instrument struck the titanium cover it had brought along with all its might. Data came to Earth. The ground is incredibly hard, almost like metal. Scientists scratched their heads for a long time until they looked at the photographs and saw the lying cover and the spike resting against it. It was the most expensive operation in history to measure the hardness of a camera lens cap. But even this curiosity could not diminish the greatness of the achievement. The USSR firmly established itself on Venus, turning it into its scientific testing ground. After Venera 7 transmitted its short but historic signal from the surface, a moment of truth arrived in the Soviet space program. We proved landing was possible. Titanium held up. But this wasn't enough for scientists. They resembled people who entered a dark cave by touch, felt the walls, realized it was hot, but never saw where they were. The main question now tormenting the Academy of Sciences was, is there light on the surface of Venus? It seems like a simple question, but in the early 70s, no one knew the answer. Astronomers claimed the cloud layer was so thick and dense, more than 12 miles of continuous sulfuric acid fog, that sunlight might simply not reach the bottom. There was a well-founded theory that eternal, impenetrable night reigns on the surface of Venus, absolute darkness. If so, there is no point in putting cameras on the next probes. Why waste precious weight on optics if they won't see anything? Searchlights? But over such a huge area, they would be as useless as a pocket flashlight in a forest. To resolve this dispute, the Venera 8 mission was urgently prepared. Launched in 1972, this craft looked almost identical to its predecessor, number 7. The same titanium sphere, the same powerful thermal insulation. But inside sat not a photographer, but a light accountant, a special photometer. Its task was simple: measure light levels during descent and after landing. Engineers worked in 3 shifts. They had to make the astronomical window. The pressure of responsibility was colossal. If Venera 8 said it was dark, the photography program would be closed for decades. The landing of Venera 8 was perhaps the most anxious in terms of waiting for data. The device entered the atmosphere on the day side of the planet. Unlike previous missions, it had to land where the sun was high. The descent lasted about an hour, and all this time, sensors transmitted data. Light, even brighter. When the device touched the ground, instruments showed that the illumination on the surface resembles a cloudy, rainy day on Earth or deep twilight. There was enough light. It was a green light for engineers. Cameras could be installed. We could try to see this world. But then a new, even more monstrous technical problem arose: how to transmit the picture. Venera 7 and Venera 8 transmitted data directly to Earth. The speed of such transmission was negligibly small, just a few bits per second. To transmit a single good quality photograph over such a channel, the device would have to work on the surface for several hours, and that was impossible. It overheated and died in 30-40 minutes. The laws of physics backed the designers into a corner. Either we transmit quickly, but for that, we need a giant antenna and a powerful transmitter that won't fit in the lander, or we don't transmit a picture at all. The solution was found, and it was elegant, like everything genius. Split the ship into two parts. The first part is an orbital relay that remains in space, orbiting Venus. The second part is the lander. The landing module quickly shoots all information to orbit, to the relay, and that one calmly, without rushing, forwards the data to Earth in large packets. Thus was born a new generation of Soviet heavy interplanetary stations, Venera 9 and Venera 10. These were no longer just balls. They were true space dreadnoughts weighing 5 tons. The most powerful Proton K rocket at the time was used to launch them. The landers themselves also changed. Engineers understood, for the camera to work stably, the device shouldn't lie on its side like Venera 7. It must stand firm. Therefore, a special landing toroidal shock absorber was added to the titanium sphere, a metal ring that crumpled upon impact, absorbing energy. An aerodynamic shield was added on top, which pressed the station to the ground with the incoming wind flow, preventing it from tipping over. October 1975. 2 stations, Venera 9 and Venera 10, approached the target a few days apart. For the first time in the history of astronautics, an artificial satellite of Venus is created. The orbital modules break and enter orbit, becoming the first moons of this planet. The landers dive into the atmosphere. Let's imagine this descent. It's not like landing on Mars or the Moon. It's a dive into an ocean, only instead of water, superheated gas. First, the device breaks with its hull. The plasma temperature around reaches 20,000 degrees. The heat shield burns away, carrying heat with it as intended. Then, at an altitude of about 37 miles, a parachute is fired. But, and this is an important nuance, a parachute on Venus is needed for a short time. If you descend on it all the way down, the flight will take forever, and the device will overheat. Therefore, at an altitude of 30 miles, the parachute is jettisoned. Then the device just falls. Or rather, it doesn't fall, but glides. The atmospheric density below is so huge that even a heavy metal sphere sinks in it slowly, like a stone in thick syrup or oil. A special rigid drag shield performs the role of a parachute. It was a risky decision, but it paid off. Venera 9 touched the surface in the Beta Regio. Impact. The shock absorber crumpled. The station froze. Tilt. Only a few degrees. Perfect. Inside, automation worked. Explosive charges detonated, tearing covers off camera portholes. The scanning mechanism buzzed. It must be understood that the cameras on these devices were not like modern digital sensors or even ordinary television tubes. They were optical mechanical scanners. Inside the device, a mirror rotated, collecting light line by line, pixel by pixel, and turning it into an electrical signal. It was very reliable, almost eternal mechanics, capable of working under vibrations and G-forces. On Earth, at the Deep Space Communications Center, operators held their breath. Recorders began to draw lines. The signal came in clean, powerful. The relay in orbit worked flawlessly. And then an image appeared on the monitors. It was a shock. Scientists expected to see anything: sand dunes like in the Sahara, a smooth plain eroded by winds, a solidified lava crust. But Venera 9 showed them a scattering of sharp, angular rocks. It was a scree slope. Rocks were everywhere, big, small, flat, piled on top of each other. Their edges were sharp as knives. This meant only one thing: the surface of Venus is young. These rocks hadn't lain here for millions of years, swept by the wind. They fell recently, or the process of mountain destruction is constant here. Perhaps an earthquake happened right before landing. Shadows. Shadows from the rocks were clearly visible in the photo. This finally buried the myth of eternal night. The sun, though hidden behind clouds, gave enough light. The landscape resembled a cloudy day in a quarry. No sand, no dust. Only bare, dead stone. A few days later, Venera 10 sent a panorama. It landed thousands of miles from number 9 in a lowland. And the landscape there was different. Huge, flat slabs resembling giant tortoise shells, with dark soil or solidified lava visible between them. This proved that Venus is geologically diverse. It's not a uniform billiard ball. There are mountains, plains, and tectonic faults. But behind this triumph lurked a drama not spoken of loudly back then. Each craft had 2 cameras installed to get a 360-degree panorama. On Venera 9, only one cover opened. The second seized tight, unable to withstand the external pressure. On Venera 10, the same story repeated. Again, only one camera opened. It turned out we saw only half of what we could have. Engineers tore their hair out. The cover release system, which worked perfectly on Earth in pressure chambers, failed on Venus. Apparently, the vacuum created under the cover during descent sucked it to the hull with such force that the explosive charge's energy wasn't enough. This cover problem would become a real curse of the program. Engineers would struggle with it for years, changing the design, increasing the explosive charge, changing the shape. It was a war with physics at the limit of possibilities. Meanwhile, scientists' appetites grew. Black and white photos are good, but what color is Venus? Soviet geologists wanted to know the mineral composition. Astrophysicists wanted to know the sky's composition. A task was set: record a color panorama, and even harder, record sound. Thus appeared the Venera 11 and Venera 12 missions, launched in 1978. These devices were to become the ears of the Soviet Union on Venus. A unique instrument called Groza, thunderstorm, was installed on them. It was an electromagnetic wave detector and a high-sensitivity microphone. The task was to find out if there was lightning in the planet's atmosphere. American probes flying by recorded strange radio bursts. This needed to be checked on site. Venera 11 and 12 landed in the harshest regions, and Groza worked. Instruments recorded powerful electromagnetic discharges. Storms really do rage on Venus, and they are not like Earth's. They can strike incessantly in series, dozens of strikes per second. These are real electrical storms, the nature of which is still not fully clear. Perhaps it is static electricity from the friction of ash particles in volcanic clouds. The microphones also recorded strange sounds, sharp clicks, and a hum. The aerodynamic noise of descent was monstrous, but a real disaster happened with the photographs on these missions. On Venera 11, both camera covers failed to open. On Venera 12, both covers failed to open too. 4 cameras, 4 chances to see a color world, and 0 result. It was a crushing blow to the pride of the Lavochkin designers. The devices landed, they worked, they transmitted data on atmospheric composition. They heard thunderstorms, but they were blind. The cause was again the notorious sealing of the covers. The external pressure of 90 atmospheres simply pressed them into the hull. After this failure, a tough conversation took place in the design bureau. The guilty were punished, all blueprints reviewed. The next pair of stations, Venera 13 and Venera 14, had to be perfect. Mistakes were no longer allowed. The reputation of a space superpower was at stake. Preparation for the launch of Venera 13 resembled preparation for war. New pressure chambers were created, capable of simulating not only pressure and temperature, but also the chemical composition of the atmosphere and even Venusian wind. The covers were completely redesigned. Now they used more powerful pyrotechnics and different seal geometry. But the main novelty of these stations was the soil sampling device. It was a masterpiece of robotics. Imagine, you need to drill stone at a temperature of 900 degrees. Ordinary lubricant in such conditions evaporates instantly or turns into carbon deposits. An ordinary electric motor will burn out in a second. Soviet engineers came up with a unique system. The drilling rig was outside, in the heat, but all its drives were inside, in the cooled compartment. Rotation was transmitted through special sealed feed-throughs, and the drill bit itself was made of super hard alloys. But it's not enough to drill. You need to collect the soil. How? With a vacuum cleaner? In an atmosphere 60 times denser than Earth's air, an ordinary vacuum cleaner won't work. They invented a system using Venus's own pressure. Soil fell into a special capsule. Then an explosive charge opened a channel into a low-pressure chamber. There was a vacuum inside the device. And the monstrous external pressure of 90 atmospheres shot the soil sample into the device, driving it through a system of airlocks straight into the X-ray spectrometer. It was brilliant, using the hostile force of the planet for your own purposes. In addition, color calibration charts were installed on Venera 13 and 14 for the first time. To understand the true color in the photos, one needed to know how the color of known paints is distorted. Strips of white, red, green, and blue were applied to the hull. This was the standard. Comparing how these strips look on Venus with how they look on Earth, scientists could restore the real color gamut of the alien landscape. And so, March 1982 arrived. The launch went flawlessly. The flight took 4 months. Venera 13 entered the atmosphere. Remembering past failures, engineers added new safety elements to the landing sequence. Braking was smoother. The device touched the surface softly, raising a cloud of dust. Dust on Venus settles slowly, so the cameras didn't turn on immediately, but with a delay of a couple of minutes to let the fog clear. Moment of truth. Command to fire covers, the pop of pyrotechnics. In the control center, the operator responsible for the video signal shouted, "We have opening, both cameras, the picture is coming." It was a triumph. A yellow-orange world emerged on the screens. For the first time, people saw the color of another planet's soil. It wasn't the gray concrete of the moon or the rusty dust of Mars. It was brown, porous stone, flooded with strange, sickly light resembling sodium lamps in a tunnel. But Venera 13 didn't just look. It worked with its hands. The drill buzzed, the vibration transmitted to the hull, and the microphone recorded this sound: metal grinding against stone on another planet. It was a fantastic feeling of the reality of what was happening. The drill went about an inch deep. The explosion of the vacuum chamber, and the soil was sucked inside. The analyzer began its work. At this time, Venera 14, which landed in a different area, also transmitted a panorama, and there the landscape was even flatter and more desolate. That ill-fated cover we talked about earlier fell right here, but even this curiosity didn't spoil the overall picture of victory. Chemical analysis showed these are tholites. This is a rare type of basalt found on Earth in mid-ocean ridges. This means Venus was once geologically very similar to a young Earth. These stations worked for a record time. Venera 13 lasted 127 minutes, more than 2 hours in hell. Its electronics continued to work even when the temperature inside the instrument compartment began to creep up, exceeding 100, 120, 140 degrees. It didn't die immediately. The signal weakened, interference appeared, but it fought to the last transistor until overheating finally melted the solder in the microchips. These 127 minutes became the gold standard of reliability. No other device, American or European, has ever landed on Venus after that with such a complex program. But the research program wasn't limited to the surface. While landers died a heroic death below, Venera 15 and Venera 16 relays continued to work in orbit. And their mission was no less grand, though not as cinematic. In 1983, these satellites began radar mapping of the planet. If we can't see the surface through the clouds with eyes, we can see it with radar. Radio waves pass through clouds, reflect off mountains and lowlands, and return. Venera 15 and 16 imaged almost the entire northern hemisphere. And what scientists saw on these radar maps amazed them no less than the color photos from below. They saw giant volcanoes. Maxwell Montes, 7 miles high, taller than Everest. They saw strange ring structures called coronae. These are huge rings of faults and ridges hundreds of miles in diameter. Nothing like this exists on Earth, Mars, or the Moon. Geologists hypothesize that coronae are traces of giant magma bubbles rising from the mantle to the surface, bulging the crust, then cooling and collapsing, leaving ring scars. This suggested that Venus's interior works completely differently from Earth's. There is no tectonic plate movement like ours. Venus seems to shed its internal heat through such pinpoint breakthroughs and global catastrophes when the entire crust melts and renews at once. The Soviet School of Radar allowed creating a detailed atlas of Venus. We named these mountains and plains. By international agreement, all objects on Venus are given female names: Snegurochka Planitia, Baba Yaga Canyon, Akhmatova Crater. Venus became the only planet with a female face, and Soviet cartographers drew that face. By the mid-80s, the USSR was the absolute leader in studying this planet. Americans focused on Mars and the outer gas giants. Venus was ours. It seemed this conveyor of discoveries couldn't be stopped. Blueprints for the next generation of devices were already in design bureaus. Venerocods, huge wheeled tanks capable of driving at 900 degrees, running on isotope energy sources, were being designed. Plans to return soil from Venus to Earth were discussed. This was a task of fantastic complexity. Taking off from a planet with gravity almost like Earth's and an atmosphere resisting like water is like launching a rocket from the bottom of the Mariana Trench. But engineers believed they would do it by the year 2000. However, history was preparing a twist. The Vega project became the final chord of this great symphony. Launched in 1984, its name stood for Venus and Galai, Halley. Engineers decided to kill two birds with one stone, visit Venus, and intercept the famous Halley's Comet. Unique to Vega was its cargo. Besides landers, the rockets carried balloons. Yes, Soviet engineers decided to launch hot air balloons into the atmosphere of another planet. The idea was bold. While the surface is a frying pan, at an altitude of 30 miles, the pressure drops to 1 atmosphere and the temperature is comfortable. This is the zone of life. In June 1985, 2 balloon probes separated and dove into the orange clouds. The balloons inflated with helium. They drifted in the sky of an alien planet driven by hurricane-force winds. They worked for about 46 hours, traveling over 6,000 miles. The data they transmitted shocked meteorologists. The atmosphere was a boiling cauldron. The balloons were constantly thrown up and down by vertical air currents. One probe recorded flashes of light, lightning. The Vega mission was a triumph. We proved we could fly in the atmosphere. But in the late 80s, the Soviet economy began to crack. Perestroika and the collapse of the country put an end to expensive interplanetary ambitions. The program was canceled. A generation of knowledge was lost. Since 1985, no human-made device has made a soft landing on Venus. We just left, leaving the door open, but never returning. However, Venus didn't let go of scientists' minds. Decades later, old Soviet data sparked a sensation. In 2012, Leonid Xanfomaliti, a scientist involved in the Venera missions, published an article claiming there might be life on Venus. Reanalyzing old photos from Venera 13 using modern digital processing, he identified strange objects, a disk that changed shape, a black patch that appeared and disappeared, and the scorpion, a complex structure resembling an insect that emerged from the soil and then vanished, leaving a groove. He suggested we might have encountered a different form of life, perhaps nitrogen or silicon-based, living in liquid sulfur. Most experts were skeptical, attributing the artifacts to noise or debris from the lander. But the seed of doubt was sown. And in 2020, a new sensation hit. Astronomers announced the discovery of phosphine in Venus's clouds. On Earth, this gas is a biomarker produced only by living organisms. This discovery made everyone remember the Soviet Vega balloons. They flew exactly in the cloud layer where phosphine was found. Suddenly, the hypothesis that Venus is habitable not on the surface but in the sky looks realistic. Today we stand on the threshold of a new assault on Venus. Russia plans Venera D, long-lasting. The US prepares Da Vinci Plus and Veritas missions. Europe prepares Envision. Why do we want to go back to this hell? Venus is a warning. It's a mirror reflecting Earth's possible future. Scientists believe Venus was once Earth's twin with oceans and a mild climate. But then the climate control mechanism failed, starting a runaway greenhouse effect. Studying Venus, we try to understand the point of no return for climate change. But there is also a philosophical side. The Soviet Venera program is a monument to the human spirit. Those devices, Venera 9, 13, 14, are still standing there. Darkened, perhaps deformed, but standing. They are the only man-made monuments in that world. They found proof that we are not locked on Earth, that our eyes can see landscapes of other worlds. Venus is a cruel mistress. She killed every device we sent. But before dying, those brave little robots shouted across the abyss, "I am here, I see, look." And maybe one day, our distant descendants, walking through the cool forests of a terraformed Venus, will stumble upon a strange, ancient machine, half embedded in rock. They will wipe off the dust and see a faded inscription in Cyrillic, CCCP, and they will understand they were not the first. That the path to the stars was paved by the titanic work and sacrifices of those who lived thousands of years before them.